Today we are starting Unit 4. We have to, yes. I think it's a pretty fun unit, but that's just my opinion. Oh, I need your one.
There's always freaking so many.
Pass up your warm-up sheet.
I get so angry. It's always like, oh, A is this person, then A is this person, then A is this person. I'm like, oh, that's so upsetting. No, you can't do that. I love you.
Bro, you don't have your name on it. What are you doing? Do you want credit?
Alright, you guys need to put your Chromebooks away. Phones and Chromebooks to be put away.
I saw the new skyscraper yesterday. It was good. Did you hear me in the building?
Okay. So we are starting Unit 4, which is basically like a mini unit over probability and statistics. So it is very, very different from some of the other things we've been doing. So if you have hated what we were doing about quadratics, then you might love this. If you really liked some of the stuff we've been doing, like with quadratics and things like that, you might not like this. Okay, so there is a probability and stats class that you can take. So if this unit is something that you really like, you might want to consider taking probability and statistics because it is a separate class. This is kind of just a little introduction to it. Okay, so our first section is on something called the multiplication counting principle and permutation. Okay, so we're going to figure out basically how many different ways you can do something. Are they what?
Are they always word problems?
They're all word problems pretty much, okay? So, it says at the top, there may be a situation in real life in which you want to count the number of possibilities. For example, if you go to a sandwich shop, you may be able to choose from ham, turkey, roast beef, or salami, and also have a choice of white, wheat, or rye bread. It says how many different sandwich combinations are possible. Okay? So it says one way that we can do this is by making a tree diagram. This is not the most efficient way, but we're going to start by making a tree diagram to figure out how many different sandwiches we can make. So I'm just going to list all my different lunch meats. So we have ham, we have turkey, we have roast beef, and we have salami. Okay, so if I want ham on my sandwich, I can get 3 different kinds of bread, correct? White, wheat, or rye. So I could have ham on white, ham on wheat, or ham on rye. Or I can order turkey. I can get turkey on white, turkey on wheat, turkey on rice. Or I can order roast beef on white, roast beef on wheat, or roast beef on rice. And last, I can order salami on white, salami on wheat, or salami on rice. Okay, so however many branches on my tree diagram that I have is how many options of sandwiches I have. So how many? 12. So there's 12 12 different combinations that I could order.
So could it be 16 because the answer equals B because it's a lobby?
That's what I'm saying. You could put all of them on one.
No, that's all. So like I would say
Or you could have Human Turkey on one.
Okay, so we're just for right now figuring out one lunch meat and one bread. Okay.
Yeah.
Yes, there's other options if the plate lets me put 2 meats on one bread.
For each slide you have white, meat, white, and ham.
I know. So how many? Mark 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
So you don't add meat into the number? Because I thought you put a
If I wanted just meat without bread.
That's basic.
But that's not a sandwich, right? So we're trying to figure out how many sandwiches. Okay?
No, I feel
Okay, so 12 different sandwiches. Now, could I have figured that out without making that diagram since that took us a minute?
I literally solved it in 2 seconds before you even started.
Okay, how would I do it without making diagrams?
Times the bread by the meat.
Times the kinds of bread by the different kinds of meat. So 3. We're really chatty today. We have 3 different kinds of bread and 4 different kinds of meat. 3 times 4 is 12, right? So baking a tree diagram may not be the best option, especially when we get more choices. Okay? So the multiplication counting principle is what we just said. You just take the number of each choice and multiply it together. I can do it for 2 events. 2 events means like 2 things, like meat and bread. I can do it for 3 or more. So if we wanted to figure out a meat, a bread, and maybe like a veggie that we're putting on top, we could have done it that way too. So we just multiply the different choices together. Okay? So we're going to do another example. This one says, police use photos of various facial features to help witnesses identify suspects. A basic kit contains 195 hairlines, 99 eyes and eyebrows, 89 noses, 105 mouths, and 74 chins or necks. So they have all these pictures of different facial features, and they can put them together to make a face to try and identify a suspect. It says, police say the kit can produce billions of different faces. Is this correct? So we're going to figure out how many different faces we can produce. And we're going to need a calculator, so that's why I'm bringing them around. So how do you think we're going to do it? Multiply everything together. Do you not need this?
No, stuff like
You're going to need one for something we do on the back. I don't think your phone's going to do it. Okay. So we are just taking 195, multiplying it by 99, multiplying it by 89 noses, 105 mouths, and 74 chins.
I feel like it's still not enough to like categorize a lot of people. In the world. Yeah.
I mean, it's not exact, but it would make a lot of different people. Alright. Did we get it?
Yeah.
How many different faces?
13 billion.
1.334998665 times 10.
you lost me at 1.
Okay, so it put it in scientific notation.
Yeah. Because it's so big. Maybe it is more than
It is.
it's more than the amount of people realize.
Okay, so it gave it to you like this,
Almost twice as many.
right?
Yeah. I got it.
You guys know scientific notation? This is, yeah.
It only gives you 80.
Okay, so we have to like add a 0, right? Is that over a billion?
Yeah.
Or it says, can it produce billions?
Yeah.
For sure. 13 billion to be exact. So is it correct? We would say yes. Alright. says a witness can clearly remember the hairline and nose of a suspect. So they look at all the pictures of hairlines and noses and they pick one out. Kind of weird concept.
Detailed.
How many different faces can be produced with this information? So they specifically know the hairline and the nose. So how would I figure this one out? No. But that was a good guess, Peyton.
You divide it by what?
No. Okay, good. Zach said we multiply everything except for the hairline and the nose. So one way you can think about it is there's only one possible hairline and only one possible nose, and then I still have 99 possible eyes, 105 possible mouths, and 74 possible chins. So I would just multiply basically 99, 105, and 74. Which would be, can we do it yet?
769,230.
Okay. So that limits it quite a bit. Do that.
Oh, I have her shirt.
All right.
Oh, okay, never mind.
What's wrong?
Nothing, I'm not going to
You got a calculator.
Yeah, I didn't write it down.
All right. Example 2 on the back. It says the standard license plate in New York contains 3 digits. So digits are numbers 0 through 9. That's a digit, a single number, followed by 3 letters. We know that letters are A through Z. There's 2 questions. The first one says, how many different license plates are possible if the digits and letters cannot be repeated? It's literally on camera right there. It says the letters cannot be repeated. Okay. So let's imagine a license plate. 3 digits. I'm just going to make one up. Let's say it's 329 and then 3 letters. Okay. Oh, I'm going to use my initials. Yes. Here, okay, so there's 6 spots on the license plate, right? The first spot is a digit. How many possibilities? How many choices? Remember, we're talking about choices. 0 through 9. There's really 10, right? Because if you count 0, that makes 10. So right here, that first spot, there's 10 options. There's 10 choices. Does that make sense? Okay. My second spot on my license plate, I put a 2 on mine, but how many choices? But it says they cannot be repeated. So now there's only 9 for my second spot. Because I already used one of my numbers, so now I only have 9 numbers left that could go here. My third spot is also a number. 8 choices because I've already used 2 numbers. Okay, then the next spot is a letter. How many letters are there? 26. I cannot repeat. How many letters here? There could be 25, and then the last spot? 24. 24. So you are multiplying 10 times 9 times 8 times 26 times 25 times 24. Okay, did we get 11,232,000?
Yes.
Perfect. Alright, the next part, it says how many different license plates are possible if the digits and letters can be repeated. So the only difference is that we can repeat letters and numbers. is still the 6 numbers and letters. Okay, so digits, we have 10 different digits. They can be repeated. So how many options for my second spot? 10. And my third spot. 10 again. And then my fourth. And then my and last. Okay. So they're allowed to be repeated, so I can use all 26 letters every time and all 10 digits every time. What did we get? Good? Okay. So, that has to do with something called the counting principle. You just multiply all the different choices together. Now we're going to switch gears a little bit. We're going to talk about something called permutations. Permutations are different ways that I can order something. So it's not just choices, it's different ways that I can put something in a certain order. So it says an ordering of objects is called a permutation. For instance, if I have the letters A, B, and C, how many different ways can I write them? Okay, well let's see. I could do A and then B and then C. What else could I do? A, C, B. C, B, A. C, A, B. B, C, A. B, A, C. Any more? No. How many? There's only 6. There's only 6 because I'm not going to repeat any letters. So I'm not going to have like A, B, A. I just want to use them once. So it says in general the number of permutations or the number of ways I can order something is called n factorial. So that exclamation mark that you see here is called in math a factorial. What it means, so if I wanted to figure out how many different ways I can order these, there's 3 letters. I could do 3 times 2 times 1. That's what a 3 factorial represents. A factorial means you start at the number and you multiply by everything smaller than it. We know 3 times 2 is 6, 6 times 1 is 6. So that's how I could figure it out. Because if they gave me like 5 letters, I wouldn't want to write it all out. Okay? So we're going to find permutations, so we're going to have to use this factorial concept. So if I had like 5 factorial, I would do 5 times 4 times 3 times 2 times 1. Does that make sense? Okay. And we actually have a button on our calculator that does factorials for us. So that's why I gave everyone a calculator as well. So, example 3. 12 skiers are competing in the final round of the Olympic freestyle skiing competition. 2 parts. The first part says, in how many ways, that basically means how many orders, can the skiers finish the competition assuming there are no ties? So basically, how many different places can they finish it? So how many skiers are there? 12. So 12 can finish, 12 have an opportunity to finish first. 11 have an opportunity to finish second. There's 10 left to finish third, and so on. Does that make sense? So what it really is a 12 factorial. You can either do on your calculator 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or I can show you the factorial button, which will be very helpful. So you need to type the 12 first. There is a button that says PRB on it. Do you see that button? Stands for probability. It's right underneath the degree button. If you press that PRB button and you scroll over to the exclamation mark and press enter, and then enter again, it gives you So we should have got 479,001,600. Did we all get that?
Yeah.
Perfect. Alright, the next part, it says, in how many ways, so basically how many orders, that means it's a permutation, can 3 of the spheres finish first, second, and third with gold, silver, and bronze? Any ideas how we would figure this one out? Jonathan?
You just take 12.
Yep, perfect. He said you just do 12 times 11 times 10. So 12 people can get first place. One person already won first place, so that only leaves 11 people left to get second. And then there's only 10 people left to get bronze. So you're just doing 12 times 11 times 10. So you don't really need your factorial button for this one. You can just multiply those 3 numbers. Which is what?
1,320.
Alright. The next part gives us a formula for when we're trying to figure out permutations of a certain object taken from a group of distinct objects, which sounds kind of confusing. So like, if you have like maybe if there's 20 of you in the classroom and I'm choosing 4 of you to line up in front of the classroom, this is a little formula that I would use to figure out how many ways can I choose 4 of you to line up from the 20 in the classroom. So it's n factorial, n is the total number in the group, divided by n, the total number, minus however many I'm choosing, the factorial of that. Okay? So it'll make more sense when we go over these examples. It says, you are considering 10 different colleges to visit before you decide to apply them. In how many orders can you visit those 10 colleges? This part's the same as what we just did, pretty much. How would I figure out how many different orders can I visit 10 colleges? 10 factorial. I could visit 10. There's 10 options to go to first, and then I already went to one, so then there's 9, and then there's 8, and then 7, 6, 5, 4, 3, 2, 1. So what is 10 factorial? 800. Okay. The next part says, in how many orders can you visit 6 of them? Now, we can either use this little formula that's up here, or we can kind of use the same concept with the skiers that are finishing in first, second, and third. So I want to go to 6 of my colleges. There's 10 total that I'm thinking about. So I have 10 to choose from first, and then I have 9, and then 8, and then 7, and then 6, and then 5. And then there's my 6 colleges, right? There's 6 numbers here. Does that make sense? So I can do it that way. I can do it actually in 3 different ways. This will for sure give me the correct answer. Or we could use this formula up here. So n is the total number of colleges, so I could have done 10 factorial divided by 10 minus 6 factorial. There's 10 and I'm choosing 6 of them to go to. Which is 10 factorial divided by 4 factorial. You could also do it that way. You would just do 10 factorial on your calculator, enter, divided by 4 factorial, enter. Okay, and then I have one more way we can do it, so I'm going to show you another button on our calculator. If you go back to that probability button, do you see something that says NPR? Okay, the P stands for permutation. We're figuring out permutation. So, if I have N as my total number, 10 colleges, I can use that NPR button. I could type 10 and then go to the NPR button, and I'm choosing 6 of them to go to. I could type 10, then go to that probability button, click NPR, and then type 6, and then enter. And you should get the same thing. Did you do the same thing? Perfect. There you go. 3 different ways you can do it. Once you get used to using this button, you will probably want to use this button the most. Okay, now we're going to talk about how many different ways we can order something if we have something that repeats. So we're going to talk about words like Ohio and Mississippi. We want to know how many different ways can I write the letters Ohio and Mississippi, but we have to keep in mind that we have some letters that repeat. So we have a little formula right here. N is the total number of letters. So we do n factorial. And we're going to divide by however many times a letter repeats itself. That's Q. So if I have an K that appears twice, I would divide by 2 factorial because it appears 2 times. So look at Ohio. We want to know how many different ways can I write out Ohio. But we have to keep in mind, if I switch this O and this O, it would still say Ohio, right? So that's why we divide, because we want to eliminate those repeats. So how many letters in Ohio? So we do 4 factorial. And then which letter repeats? Oh, and how many times does it repeat? 2. So we're going to divide by 2 factorial. Factorials are a little different, so you can't just say, oh, 4 divided by 2 is 2, and then you do 2 factorial. That's not how it works.
When you look at the 2 factorial,
Because I have 2 O's.
oh, so you're trying to get rid of the O's.
So you need to do 4 factorial divided by 2 factorial on your calculator. You can just do 4 factorial, enter, divided by 2 factorial, enter. Or if you didn't have a calculator, remember it's just 4 times 3 times 2 times 1 divided by 2 times 1. What did you get? Okay, you could also cancel those out since they're the same, and 4 times 3 is 12. Alright, the next one says Mississippi. How many total letters? 11. Okay, 11 total. What do I have that repeats?
Yes.
Okay, how many S's?
4.
So we divide by 4 factorial. Do I have anything else that repeats? How many I's? 3, right?
12. In between the I's.
No. So I'm going to divide by another 4 factorial. What else repeats? P. So there's 2 P's, so I also divide by 2 factorial. So this one's a little more complex. You can either use the factorial buttons.
And this number is supposed to be used.
When you do your, on the calculator, if you do 11 factorial divided by, make sure you put this part on the bottom in parentheses.
Oh.
Okay, because you're dividing by that whole quantity. If you don't put it in parentheses, you won't get the correct answer. So if you're dividing by multiple factorials, use parentheses.